Hello everyone. Today in this session we will discuss the engine starting system which is utilized in IC engines. Engine starting system is defined as a system which brings engine at full running condition so that it will develop a power. Now we will see what are the requirements of an engine starting system. Generally, IC engines are not self-starting devices. So to start the engine, a manual or electric cranking is required. Now, in that case, if that cranking speed is at around 100 rpm, then engine can develop adequate power required for an engine to bring it at full running condition. So, while approaching this cranking speed, a sufficient torque of 10 to 30 Newton meter is required in case of the light duty engines, while a torque of 50 to 150 Newton meter is required for heavy duty engines. For minimum efforts, a torque applied should be minimum to crank the engine. Hence, generally 15:1 is the cranking ratio required between motor and flywheel. It means when motor will run at 1500 rpm, then flywheel will run at 100 rpm to crank the engine. So, according to capacity of engine, an adequate power source must be utilized to crank the engines. Now we will see what are the different methods of starting the engine. In initial development of engines were generally cranked or started with manual operations like kick starting for motorcycles and cranking handle in case of the cars or heavy duty engines. Nowadays, electric starting is utilized in all the automobiles, which is the effortless and easiest way of starting the engine. Along with electric starting, compressed air starting is also utilized in high-speed diesel engines, gas turbines or gas engines which are utilized in the marine application. Talking about the compressed air starting, here a compressed air of 20 to 30 bar is admitted in the engine cylinder through the inlet valve, which makes that piston which is at top dead center to move at bottom dead center and to create the initial cranking through this reciprocating action and transfer that one to the flywheel in terms of the rotating motion. So this kind of the cranking can be also observed in case of the diesel engines or the gas engines which are utilized in the marine application. Now we will discuss in details what is electric starting system. First of all, we will try to understand what are the basic components of electric starting system. The very first one is the starter switch. This starter switch closes or make the starter circuit to energize the starter relay. The starter relay is nothing but one which controls the opening and closing of the circuit from battery to the magnetic switch. Now, this starter switch is having 4 key switch positions which you can observe in this photographic view. The first one is lock position. In this position, all circuits are open, means no current will be supplied. Also, it makes the steering wheel in lock position. The second position is ACC. Here, in second position, all circuits are closed, but ignition and starting circuits are still open, means current only flow through the accessories like radio, car tape, AC, power windows, etc. Then the third position is on position. In this position, now current will be supplied to starter system only and all other circuits remain open. And the last position is start position. Now in this position, when key is operated from on position to start position, current will be supplied to both starting and ignition system, and rest of all accessories now will stop functioning as their circuits are open. Here the starter switch which is utilized is spring loaded. So once the engine is started, then it again comes to on position. So when it comes to on position, starting circuit again gets open because now engine has started running on fuel energy because of ignition system circuit. Also, once key comes to on position, all other accessories again start functioning. So this is how 4 positions of starter switch are working. The next component is starter motor. In present slide, we can observe photographic view of starter motor. The role of starter motor is to convert electrical energy into mechanical energy. In automobiles, a DC starter motor receives an electrical energy from battery and converts it into the mechanical energy. Here, rotational motion available in starter gear of the starter motor is transferred to the flywheel so that it will start rotating. This provides a required cranking speed to the engine. Starter motor is provided with the solenoid switch, or you can say magnetic switch. Now in this next slide we will see how a magnetic switch is working in starting system. In the schematic you can observe the detailed construction of magnetic switch. Basically, magnetic switch act as a relay and connect battery to the starter motor. In the schematic, you can observe there are different components in the magnetic switch. Number 1, there is a terminal M which will be connected to the starter motor. Then there is a terminal B which is coming from the starter switch. Then there is a contact switch. Also, we are having a plunger in connection with the contact switch. Then we are having the hold-in coil as well as the pull-in coil. We will see later on what are the functions of this hold-in coil and the pull-in coil. Then this one is the shift lever. This one is nothing but the overrunning clutch and the pinion. So likely this is what we are having the different components of the magnetic switch. As I said, the magnetic switch act as a relay and connect the battery to the starter motor. A small current is used to energize the pull-in and hold-in windings of the magnetic switch, which enables a large current to be get passed from battery to the starter motor. Here in this assembly, a shift lever is also connected to the magnetic switch. As the plunger is pulled towards the contact switch, a shift lever is moved forward to engage the pinion of the starter motor to the ring gear of the flywheel so that the pinion will transfer that rotary motion to the ring gear of the flywheel. Here, the pull-in windings is get energized when ignition switch or the starter switch is turned on to the start position. Then magnetic field generated attracts the plunger towards the contact switch. Secondly, we are having the hold-in windings. This winding keeps the contact switch closed until the ignition switch is switched back to the on position. So this is what we are having a simple working about the magnetic switch. Now we will see exactly how this electric starting system is working for the IC engines. Now in this schematic we can observe there is a circuit diagram which consists of battery, starter switch, starter relay, then a starter motor, then a magnetic switch or a solenoid switch, then a overturning clutch, a pinion of starter motor and a flywheel with a ring gear. Now we will see how exactly this electric starting system is getting operated. So here, when an ignition switch or starter switch is turned to start position, the starter relay is getting energized and the relay switch is getting closed and thus allowing current to flow from battery to the terminal S of the magnetic switch. The current flow through the pull-in coil, creating a magnetic field around the coil. The plunger is then pulled backward, forcing the pinion forwards and allowing it to mesh with the ring gear of the flywheel. When the armature now rotates, it rotates with the pinion which is already engaged to the ring gear of the flywheel. In this way, engine is getting cranked. Once the engine has started, the ignition switch must be turned to on position again so as to cut the power to the magnetic switch. Here, the overturning clutch is utilized. This overturning clutch protects the starter motor from excessive speed, which can cause a damage to the starter motor as well as ring gear. So this is how electric starting system is working.